In this problem, we have a 330 milliliter solution of hydrobromic acid with a pH of 1.21. We want to know what the mass of hydrogen bromide used to create the solution was. So here we're going to have to do some pH calculations. We are told that the pH of the solution is going to be equal to 1.21. We know that the volume of the solution is equal to 330 milliliters or 0.33 liters of solution. Remember, we're just going to treat that as water. We also are looking for mass, which means we're going to need the molar mass of hydrogen bromide, which is just HBr. That is going to be 80 and 91 hundredths of a gram per mole. So first thing we're going to do is we are going to need to convert this pH into a concentration. So the concentration of hydronium ions in any given acidic solution is equal to 10 to the negative pH. So if I want to know what the hydronium ion concentration is, that is going to be 10 to the power of negative 1.21. That is going to give us a concentration of 6.166 times 10 to the negative 2 moles per liter. Remember, pH doesn't have units because we've run the units through a logarithm, so it doesn't really make sense to try and write those units, but concentration still does. So we do need to include the moles per liter. Now, you'll notice that what I did is I calculated the hydronium ion concentration here. But what we're actually being asked about is the hydrobromic acid. But because hydrobromic acid is what we call a strong acid, the concentration of the hydronium ions is going to be equal to the concentration of the hydrobromic acid itself. So when I calculate the concentration of hydronium ions is 6.166 times 10 to the negative 2 moles per liter, I know that's also going to be the concentration of my HBr. Now we can just use unit canceling. What are we looking for in the end? Small correction, my molar mass should have a big M because what I'm looking for in the end is little m, grams. So I know that I have grams as part of my molar mass. I also have to cancel out my moles, which I can use my concentration for. And then I have to cancel out my liters, which I can use my volume for. So what this will look like is my mass is going to be equal to 80.91 grams per mole. Remember that the moles on the bottom really has a 1 in front of it, so it is a fraction. We've got grams on top because I want grams on top in my final answer here. Then I need to just cancel everything out. 6.166 times 10 to the negative 2 moles over liters. I'm arranging the moles so that the moles on top and the moles on the bottom are going to cancel each other out. And then I need to cancel out the liters on top as well. I do all of those calculations, and I get as my final answer 1.6 grams. Now, why is it 1.6 here? pH does something a little bit funky with significant digits. My original pH was equal to 1.21, but only these digits after the decimal place count as significant. The number in front of the decimal place is not considered to be significant, because what that actually indicates is not the measurement value, but the measurement's magnitude. Whereas the decimal place, relative to the actual value, which is only recorded in the numbers after the significant digits. So we only have 2 sig digs in this pH, so we have to have 2 significant digits in our final answer as well.